Okay, let's finish up 10.3. We continue with 25 on page 692. So we have x squared plus y squared equals 4y. They're asking us to find a polar equation this time from this representation. Okay, so what we know again, those three equations, x squared plus y squared equals r squared. And we know that x equals r cosine theta, and then y equals r sine theta. That's all we have. Well, it's very clear that r squared must be 4y, and I will replace y by this. So r squared equals 4 times r times sine theta. Simplify both sides by r. So r equals 4 sine theta. And this is the polar representation of that, which is also a circle, as we know from the previous example. Okay, final example. Let's work on graphing, which is quite cumbersome. So r equals 3 cosine 3 theta. Okay, I'm going to show this with the graphing calculator as well as I will record the steps on the computer in Zoom just to make sure that this is clear. But I'll also show it here. So you don't have to do both, but I will record both. Okay, so obviously this is an equation in polar coordinates, and we want to graph it. What I would normally recommend is to graph this when I recommend it. So at least I would go with 30 degrees. So I'll say 30, 30, 30, and 45 in the middle. So this will be 45, and this will be 30, and this will be 30, and again here 30, 45, and 30. Why do I need these rays? It's because for each point I will have to have an angle. So one point could be, let's say, at 2 units and 30 degrees, so it will be here. Another one could be at 3 units and 45 degrees, so it will be here. I'm going to erase this. It could be, the next one could be at 4 and back to maybe 30 degrees. I don't know how the graph will look like. So that's why we need these rays to help us graph. So let me erase this. Good. You may want to even go through 15 degrees. I don't know. So it depends on how detailed the graph or how difficult the graph is. Good. So here's what we do. We go to the mode. I hope you can see this. Can you see this? Yes, I think so. And make sure that you change from function to polar. So then if it's, you already have it in polar, not function, not parametric as we already did, but polar, go to y equals and enter this function. So this is 3 cosine 3 theta. 3 cosine 3 theta. Okay. So at this point, I am going to change from the table set, from second to table set, from the independent in ask mode, but the independent in auto mode. Here's why, because I don't want to enter each and every angle, 15 degrees, 30 degrees, of course in radians, 45, 60, and so on and so forth in radians, not in degrees. So I would like the calculator to start at 0 and have an increment maybe of, let's say, pi over 6 divided by 2, which is pi over 12, which is 15 degrees, right? So I enter second pi divided by 12. So I want the increment to be every 15 degrees, 15, 15, 15, 15, 15, 15. And depending on what I get for the R. Okay, so it's done. And now I want to do the second table. And I want the calculator to have all these. Otherwise, I have to enter them by hand, one by one. Okay, so let's start. So it says, the first one says when theta is 0, R is 3. Okay, 1, 2, 3, right here. Then 15 degrees, and R is 2.1, so it's right here. So for the angle of 15 degrees, R on the ray of 15 degrees, R is 2.1. Then it's at 0. I see something like this so far. Okay, and the next one, so 1, 2, 3. So at 45 degrees, for 45 degrees, I have to make sure that that is 45. So 15, 30, 45, yes. So at 45 degrees, we're looking at, for 45 degrees, we're looking at -2. For 60 degrees, we are looking at -3. 45, 60, 45, 60, yes, at -3. So on this ray, -3 units. Okay, moving on. Okay, for the next one, at -2, right here. So I kind of see this. And then again at 0, going back to 0. Okay. So the next one, I'm already in the second quadrant, is 2. 1, 2. Okay. And then at 3. And then at 2. So then at 0. Okay, so I kind of see this. So I'm back at 0. 303. That was 0. Okay, I have to see more. Okay. The next will be at -2. So it's on this. On this. Yes, up here, negative, yes. Okay. And then at 3, okay, at 3, and I close the circle. Okay, I know this is not very easy. So we can write somewhere that R equals 3 cosine 3 theta. Can we graph this? Yes, we can. So we just press on graph. We may have to adjust the viewing window or not. I see, let me just check one thing. So theta maximum to pi. Okay, yeah, let's see. Here it is. Okay. Again, graphing these are not, it's a little cumbersome. You have to change the table into from ask mode for the independent, from ask into auto, and make sure you use the increment that you need, which is here. So you start at 0, as we did initially. It changed because I changed the viewing window, but the increment is important. Right, so it changed what I entered. I entered from 0 to the increment. I used the table, the delta x. I used pi over 12, which is 15 degrees. just to make sure that I'm getting enough points to be able to graph it. Thank you.